The second part of this hackathon is going to be a decentralized part requiring Solidity. So let's make sure that we are writing the proper, excellent code that the arbitrage, the juries of the hackathon would accept. So before we start, I'm going to talk about the Solidity best practices, and obviously this conference, this audience is split into like few groups of people, starting like from the business people who potentially are afraid of Solidity at all, and then to the really, really experienced Solidity users. So I would like to inspire the thinking that this presentation is actually like useful for every category, because if you're just a business person, well, you need Solidity for two things. First of all, you always want to like go to the Etherscan, Fantom scan, and like audit the code yourself. Everybody keeps repeating that over time, like code is going to be the law basically. So if you know to audit the code and understand what it does, it means you understand what you're getting into. Secondly, it's always good to kind of be able to like gauge the experience of your developers that you're working with, or maybe you would need to participate in the Solidity developer interview over time. So that's helpful for you. If you're the starting Solidity developer, this presentation is useful because it's gonna show the best practices for you. And if you are already experienced, then, well, it's a great way to kind of validate that we are on the same page, using the same techniques and stuff like that. So first of all, my name is Arden. I represent Zokio. I'm a partner at Zokio, and we basically started with the security auditing. On the back of that, we've got so many deals going on that we have also kicked off the Zokio Labs, which is the accelerator where we take the top projects, like top picks, and we offer them the special deal in terms of accelerating them, their technology, marketing, market making, PR, everything else, partnerships, connections, for a fraction of their total token supply, and some cash or no cash from them. And then on the back of that, we do the seed series funding, so sometimes we could get a startup from like zero to a significant success. That was our value add. Hartaj, who is my partner at Zokio, he is the guy whom you probably know because Hartaj has been like super active all these years since 2013. And I think Hartaj actually started the entire like security auditing, like smart contract auditing category on the Ethereum in 2016. Moreover, more of our team members, like they were so early on in Ethereum. Like I remember some of them started in December 2015 when a lot of code was not even like documented, and some functions like you had to debug them to understand what they do. So the best practices of the Solidity is like still super important topic because Solidity remains to be the mystery to many of the developers. Of course, we are recruiting all the time, and so this is our statistics. Like, we've screened 220 candidates, and like we were able to hire only 4 developers. And here are some of the questions where the candidates fail. Of course, I'm happy to share this presentation, and I'm happy to discuss further with you in terms of like how to lead the interviews and like what tricks we use to understand whether the person is discerning or not. But before I really get into like the nitty-gritty of things, I would like to spark your interest in Solidity, because this is like a super small language. It doesn't have a lot of constructions in it. So the only thing for you to grow in it is like go really deep into how Solidity works and how to use it best of all. So some tricks that we use and we of course encourage everybody to use is, so for example, tight packing. Have you heard of tight packing before? Who is using it? Okay, some people use it. This is great. So tight packing basically means that, well, of course, you know that the storage on the Ethereum virtual machine is like super expensive. So if you are able like to pack many of your variables into like one 256 bits slot, then you'd be able to save a lot of gas on it. So, for example, kudos to Franz Wolland. He ran these tests where he packed the previous example. In this previous example, he is basically like packing many of these variables. As you see, many of them are really small. So if you are, for example, storing the timestamp, you don't need to like use the entire unsigned integer 256. So you would detect how many bits you need to pack your variables, and then you will basically like pack these variables in a way that, in fact, they will use only like one slot of memory. Another interesting, and yeah, please pay attention that you were able to save almost 2/3 of your gas on the saving. Every time somebody is saving using this smart contract, they are using like only 1/3 of the gas that they would use if it was not optimized. Another interesting example that I've almost not seen people use in real life, although it's like super handy and like you can find the use cases for it every day, is like the gas refund. Of course, we know that gas refund happens when the transaction fails, but not many know that you can actually refund the gas if you free up the storage on the Ethereum virtual machine. And the two ways to do this is to free up the particular slot, or you can destroy the smart contract and you'll get refunded too. Of course, there are caveats to this. For example, like you cannot refund more than 50% of the overall transaction gas, but you can definitely like pack the removal and free up instructions with some other code that is doing like functional stuff, and therefore you're just saving 50% of your transaction. Another example of like people being discerning and actually like figuring out that modifiers can do much more than we've originally thought, because they can accept all the parameters that are available in the scope of that function that they are included in. So whatever parameters you pass in the function will be also available for you in the modifiers. We've got like an entire list of recommendations on how we build our product, because well, usually building the Solidity-based product means that you've got like 3 types of developers working on it: the front-end developers, the Solidity guys, and then the back-end developers. So some of the coordination is needed. We usually start with the high-level diagrams of the smart contracts. So we'd like to project the roles that people will have on those smart contracts and how the smart contracts will interact with the users and with each other. Also their functionality. If your solution is somewhat complex and you foresee that you'll have like different states of the system or any kind of like workflow management, we also encourage to kind of abstract and encapsulate the workflow management in the separate smart contract or the modifiers to ensure that a user is able to move the system from the state A to the state B. Important also that the interaction between the front end and the back end like needs to happen according to the diagram in first place. And secondly, you need to, before even like start developing, decide for yourself how you're going to use the smart contracts in terms of the feed of the information. The actual issue that has existed for a long time, and many developers had this basically dilemma, whether they should use the smart contract as a lean storage of the facts on the event log, and then after that you basically would have to extract all the information from by querying the events and then visualize it on the user interface, or whether you have to implement the query functions in the smart contracts themselves. Thankfully, solutions like the Graph, who do indexing of blockchain, have resolved that. So now you have got the backend layer where you could basically like abstract, index, and reformat your information and then feed it out on the user interface. If you want to dig deeper about like the concepts of it, I would highly recommend reading the book called Event Sourcing by Martin Fowler. It's been out there for maybe 10 years now, and really useful for complex systems and for blockchain, because basically smart contracts is nothing else than the event-sourced implementation, where you basically store the like all that has happened, but then after that you have to project the actual state of the system based on the events that have happened. Next, we recommend to define the libraries you want to use, and we often tell clients and partners, like, please use OpenZeppelin or other pre-audited or audited solutions. For example, this is how our typical ERC20 smart contract looks like. So as you can see, we have we are importing 3 library templates, and then the code itself just takes 7 lines. If you're non-technical and you are seeing the ERC20 contract like taking too long of your digital paper, too many functions and stuff, you should probably ask your technical team whether they have considered just using the audited solutions and just be as minimal as possible on top of those. Okay, also what is super important is try to figure out whether your smart contract has to be entirely immutable or upgradable. So I would like you guys, who of you are using the upgradable smart contracts? All right, and who is not using? Okay, almost equal, but more people using upgradable, and this is indeed a great practice for few use cases. First of all, it is a way for us to save gas if we want to have multiple instances of the same contract with the same functionality. So basically what you are doing is you are keeping the storage, the actual data in the proxy contract, which is like super lean because it almost doesn't have any functionality, and then multiple instances of these proxy contracts are talking to the same functionality, to the same implementation smart contract to execute the functions. And of course, the second great advantage of using the upgradables is that you can upgrade the functionality over time. Of course, the issue, though, is that you are allowing the administrator of the entire upgradability structure to replace the functionality, so you should be aware of that. We've seen cases where people have, let's put it this way, they have leveraged this. Now, we also defined the list of tasks. Yesterday, I have spoken about the entire security auditing stuff, like our framework and principles. Today, though, I would like to focus on some of the economical things, and usually what we focus on is hacker attacks, lockup of funds, and we always recommend to consider the functionality for salvaging the alien tokens, which means that if your smart contract is designed to work with a particular asset, but for some reason uneducated users are sending their funds and other tokens to that smart contract, so you'd be able to extract that out and basically redistribute back to the users. Important is to think about the economic vulnerabilities. So some that we see, well, first of all, the inflation. Of course, it's super fancy nowadays to organize the yield farming strategies with the rewards in the native token. Beware, though, that over time it would just create massive inflation, damaging the early holders of your token. Secondly, we always consider the arbitrage opportunity. So every time when you have a functionality that is arranging the trading or the price discovery or price determination by a certain formula, please consider if there is not any other pool on other platform that is also defining or deciding on the price, because then the price could differ between your pool and the other pool, and that would create the arbitrage opportunity that with the flash loan attacks could cause massive exhaustion of funds. Other issues are around the snowballing arithmetic flaws. Usually it's due to the rounding, so if you cut off like few less digits of your, like after your arithmetic operation, you should be thinking it's actually all right. But over the long period of time, and we've seen this in our tests, this could cause like a really huge deviation from the expected results. And we always test for the extreme range cases. In terms of the recommendation for the development of the smart contracts, like we also have this list that I would be super happy to share with you if you text me on Telegram or you reach back through our website. Sadly, we are out of time, so I will not go through them in detail. Before I end, it's important, though, to highlight a few things. First is we recommend to always do the bug bounty. Immunify, in our case, and to our view, is the best provider for that. We've got great relations with them. They are a super awesome team. They help every project to onboard. They've got like white glove assistance. So I highly recommend them. And secondly, we always help teams set up their quality assurance squads in-house, and that those quality assurance squads should actually do nothing but receive the new code from the dev team, remove the tests that have been written by the dev team, write the entire test suites from scratch, have a lot of like their own like spreadsheets with simulations and stuff, especially around the economics, in addition to the technical security aspects, of course. And only then are you sending the smart contracts for the external audit and then publishing it to the mainnet. That's basically it from me. I'm here in Abu Dhabi. If you also live here, happy to have a coffee with you, and thank you for your attention.
Hello, hi.
Hey.
This isn't something I think you mentioned in your slides. I also showed up a few minutes late. What's the risk reward of, would you say, using assembly in your smart contracts? So, Solidity does allow certain pieces of code to be written entirely in assembly. Some people use it for gas optimizations, increased security. I was wondering if that's something that you would recommend from a security standpoint or otherwise?
We are experimenting with the assembly, but so far we would recommend to stick with Solidity as something that is like, first of all, easier to understand. There is more documentation around it. So once we come up with the like framework and recommendations for the assembly, we'll be sharing that.
Okay, thank you.
Anyone else want to ask anything quickly? There we go, one up there. We'll take one more. Can we? There we go, thanks guys.
Hey, is there anywhere we can see the rest of the presentation online somewhere?
Is there? I think so.
You guys will be able to see all the presentations. They'll be put up there online later on.
Perfect, thanks.
Okay.
Yeah, if you want to hit me up on Telegram or LinkedIn, just text me, I'll send it to you. Thanks, everybody.